You've probably had that moment when your computer suddenly slows down right when you need it the most. Or your phone storage hits full right as you're trying to record something important. It's annoying. And it makes you wonder why our devices always seem to hit limits. We can't. This is where cloud computing steps in. Cloud computing is one of the biggest and changes the game. Leaps in modern tech. It lets us store huge amounts of data without worrying about space. It lets us run heavy tasks without expensive devices. And it lets us access everything from anywhere as long as we're online. But what's really happening behind this service? Is the cloud an actual cloud? Or just a cool term for something much more complex? The story begins with a simple need. Before the year 2010, most companies had to buy lots of physical server. They stored them in special rooms with extra cooling. The cost was massive. Every server needed maintenance, electricity, backup systems, and even then, many servers were barely used. They worked at maybe half their power. But companies still paid 100% of the cost. It's like owning a huge restaurant but only getting customers once in a while. It's wasteful. Then came a new idea. What if companies didn't own servers? What if they could rent them? Pay only when used, just like paying for water or electricity. This idea became the birth of cloud computing. And that's where our journey starts. To understand how cloud computing works, we need to go back to basics. What is a server? Think of a server like a digital brain. It stores data, runs apps, processes requests, and keeps the internet alive. But physical servers have limits. They need space, cooling, maintenance. And when they break, everything stops. Cloud computing flips this model. All thanks to virtualization. Virtualization lets one physical server be split into several virtual ones, each acting like a standalone machine. It's like turning one big house into many small rooms that different people can rent. This boosts efficiency massively. One server can serve many users without issues. But that's just step one. Behind it, there are giant data centers. Huge buildings filled with thousands of servers working non-stop. These data centers are spread across many countries, connected by high-speed networks. If one center has issues, another one can instantly take over. They're built to survive problems like earthquakes, fires, or major power outages. That's why the cloud feels stable. We rarely notice downtime. The infrastructure is layered for maximum reliability. All of this makes data accessible without us knowing where it's stored. And honestly, we don't need to know. What matters is we can access it anytime. Now let's go deeper. How does data actually move inside the cloud? Imagine you open a music app. You tap play, and the song starts instantly. But behind the scenes, the process is complex. When you tap play, your phone sends a request to cloud servers. It travels through the internet, reaches the nearest data center, and the server finds the exact music file you want. It fetches the data, processes it, compresses it so it loads fast, then sends it back to your phone in milliseconds. This instant experience is actually the work of thousands of tiny steps. Cloud computing works like an invisible orchestra. Each part has a role. Some servers handle user requests. Some store files. Some manage traffic so nothing gets jammed. If the number of users increases, the cloud automatically creates more virtual servers. This is called elasticity. Servers expand or shrink depending on demand. No human needed. This lets modern apps survive huge traffic spikes, like during concerts, flash sales, or big game launches. Cloud computing keeps everything smooth, fast, and stable. Let's see how cloud computing changes the real world. Take digital entertainment companies. Imagine a movie streaming service with hundreds of millions of users. During peak hours, millions log in at the same time. If they use traditional servers, they'd need thousands of machines ready just in case. These servers would be idle most of the day. With cloud computing, everything changes. During spikes, the system adds capacity automatically. During quiet hours, it scales back down. This saves huge costs. Education is another example. Online learning platforms struggled to handle thousands of students before the cloud. After switching, they can support millions with no issue. Healthcare uses the cloud too. Hospitals store medical records in the cloud. Doctors access them instantly from anywhere without piles of paperwork. Even small businesses benefit. In the past, only big companies could afford servers. Now small businesses use cloud services with low cost. They get premium tools without buying expensive hardware. And they grow faster without worrying about storage limits. Even though cloud computing sounds perfect, there are common misconceptions. Some people think cloud data is 100% safe automatically. But safety still depends on how users protect their accounts. The first mistake is weak passwords. Even if the data center is secure, a weak account can be hacked easily. The second mistake is not understanding cloud service types. There are three main models: infrastructure service, platform service, software service. Choosing the wrong one can waste a lot of money. The third mistake is assuming the cloud is always cheap. If you leave everything running, costs can skyrocket. It's like turning on every light in a building and never switching anything off. Bills go up fast. The fourth mistake is not checking data center location. The farther the server, the slower the app. Many new businesses learn this the hard way. They pick the wrong region, and users complain about lag. The fifth mistake is skipping backups. Some people think the cloud backs up everything automatically, but not always. Some services need extra setup to protect data properly. At its core, cloud computing is more than technology. It's a shift in how we work, store, build, and communicate. The cloud makes small devices feel powerful. A low-cost phone can access computing power equal to a supercomputer. Students can build advanced apps with little money. Small businesses can compete with giants. This is the modern world powered by the cloud. And it's still evolving fast. Some experts predict that in the next 20 years, most apps won't run on local devices at all. Everything will be processed in the cloud. Our devices will become windows to huge computing power somewhere else. This future is being built right now. And we're part of it. If you like content like this, click the subscribe and like button to support this channel and share it with friends who need insights like this. To stay within our topic, let's dive into how cloud providers keep everything running smoothly behind the scenes. Most people only see the results. Fast apps, quick downloads, smooth streaming. But the machinery that powers all of this is incredibly complex. Inside each data center, there are layers of systems working together. The first layer is the physical hardware. Rows of servers, miles of cables, cooling units running non-stop, and backup generators ready to activate in seconds. This layer keeps everything alive. The second layer is the virtualization engine. It turns physical machines into flexible virtual resources. This is what lets cloud servers grow and shrink anytime. The third layer is automation software. This system watches traffic, predicts spikes, and allocates resources before users even feel slowdowns. It's like a traffic officer who directs cars before jams happen. Then comes the security layer. Cloud providers use encryption, firewalls, identity systems, and monitoring tools that track threats every second. The security systems work around the clock, scanning millions of signals in real time, because a single weak point can affect thousands of users. All these layers combine into one giant machine, a machine that must never stop, because if the cloud stops, an entire digital world stops with it. Now let's talk about how cloud computing lets companies build apps faster. In the past, creating a big app took months, sometimes years. Developers had to install servers, configure networks, set up databases, and do everything manually. Cloud computing changes this process entirely. Instead of building everything from scratch, developers use ready-made services. Need a database? Click and it's created. Need file storage? Click and it's ready. Need user login security? Click and it's done. This is called managed services. The cloud handles the heavy work. Developers focus on creating features. This makes innovation faster, safer, and cheaper. Imagine a startup with only 5 people. With cloud computing, they can build apps as powerful as companies with thousands of employees. They simply use the tools already provided by the cloud. This levels the playing field. Anyone with creativity can compete. Another advantage is serverless computing. This system only runs code when needed. If no one uses the app, no resources are used. When people start using it, the cloud instantly scales up. This eliminates wasted money and keeps apps responsive even with huge traffic. All of this stays within our core topic. Cloud computing isn't just storage. It's a full ecosystem that accelerates how technology grows. Let's expand further on how cloud computing supports global systems. Many apps today run across multiple countries, but delivering fast performance to users worldwide is a challenge. Cloud computing solves this through global distribution. Data is placed in multiple regions, so when a user opens an app, the request goes to the nearest server. This reduces delay, makes apps feel instant, and supports millions of users at once. Cloud networks also use edge computing. This means small servers are placed closer to users, in cities, near cell towers, inside local facilities. These edge servers handle quick tasks, filtering data, caching content, or processing simple actions. This reduces load on the main cloud and keeps apps fast even during busy hours. Think of it like having mini helpers spread around the world. They take care of simple work so the main system stays efficient. This is all part of how cloud computing works. A massive, global, distributed system that feels simple to users because complexity is hidden behind the interface. To continue without leaving the topic, let's look at reliability. Cloud systems must always be available. Downtime can cause chaos. Imagine banks unable to process payments, hospitals losing access to medical records, or communication apps going offline for hours. To avoid this, cloud providers build redundancy into every layer. If one server fails, another takes over instantly. If one data center has problems, traffic is moved to another region. If a network cable breaks, data finds a new path. This is called fault tolerance. The cloud is built to survive multiple failures. There are backup power lines, backup cooling,